Now, the next step, our next common stain that's found in a microbiology lab is something called an endospore stain. Now, gram-positive rod species of bacteria are going to be the only organisms that are capable of producing endospores. Now, endospores, if you recall, are essentially going to be our little bomb-proof survival capsules for bacteria. It's a dormant form of a bacteria. When the environment goes bad, this little endospore can survive the nuclear apocalypse and can come back, reactivate itself once the environment is in a better condition for it to survive. So how do you can see these endospores? Well, they don't take stain very well at all. The vegetative cells, the non-spore producing cell at the moment, this guy can produce a cell, he's just not. He will take stain very well, just like every other bacteria species. The endospore will not. The endospore has that big, thick coating on it that's resistant to chemicals, so it will not take stain very easily. So if you do a gram stain on a gram-positive rod species that produces endospores, this is what they look like. You can see the gram-positive rod with a little white tic-tac hole in the middle of it, and that's the endospore. And you can see the endospores as well that have been released from the vegetative cell. This is a negative type stain, and you can see the endospores as well inside of them, just little balls inside of the cell. So, what are those? Are they inclusions? Is it something wrong? How do we confirm this is an endospore and not just a little ball of something inside of the cell? You do an endospore stain. And this is how you confirm that they're actually gram-positive rod-producing bacteria and not just some sort of gram-positive bacteria that has something weird up with it. So this is how you confirm that they're actually endospores. So what you're going to do is you're going to start by heat fixing your stain, and you're going to add a primary stain called malachite green. Malachite green is essentially ground up a malachite rock with an alcohol and a couple of other things added to it. That malachite green is going to be added slowly to a slide that has been put on top of boiling water or some sort of heat source to heat it up. Well, what's going to happen is that slide has already been heat fixed. The endospore cell walls are very, very, very thick, bulletproof, chemical resistant pretty much. You start heating them up, and that's going to cause the endospore cell walls to start to expand. To start to vibrate a little, or not vibrate, start to expand, to relax a little bit, to start to open up that super resistant cell coating. It's just because of the heat. The heat plus the boiling water, the steam is going to force the heat and steam. The steam is going to carry that malachite green. The heat's going to cause the cell membranes or cell walls of the endospores to open up. The steam is going to do the carrying of the malachite green from the outside of the cell, floating around on the outside, to the inside of that endospore. It forces its way through the endospore cell wall on the inside of the endospore. So what's going to happen is once that heat is applied, the malachite green is forced inside the endospores. You're going to wash away the malachite green from the slide. Now, malachite green does not bind permanently to the cells, vegetative cells. It only binds to the endospores because it's trapped inside. If the endospore cell membrane or cell wall wasn't so thick, the malachite green would be washed away. But once you remove the heat, the cell walls just go back to the way they originally were, and all the malachite green that's been forced inside is permanently stuck there. So you remove the heat source, you wash away the malachite green from the cells. It washes away everything from the background. All the other cells, the vegetative cells, all have their malachite green washed away. So the only thing that's green are the little endospores. Well, how do you see the vegetative cells? Because if you look at this underneath the microscope at this point, all you'll see is a bunch of little green dots, just like this. You're going to add a counter stain, which is called Safranin, the same thing from your gram stain. It doesn't have to be Safranin. This is just the most common one that's used. So you add your counter stain, and that counter stain is going to add color to our vegetative cells. It's going to be a primary type stain, just penetrating through the cell walls, through the cell membranes, and giving them color from the inside. So the endospores remain green, the vegetative cells become pink, and you can see the nice green dots standing out very, very obviously from the pink vegetative cells. So if you see these green dots After you've done an endospore, you know you have an endospore. If you still see colorless dots after you've done an endospore stain, you either messed up or they're not endospores. So this is how you confirm that they're endospores. And quite a lot of pathogenic species, gram-positive rod species, form endospores that are important to humans. And if these endospores can also cause problems in people as well. So that is something to note. Okay, acid-fast stains. Acid-fast stains are really interesting. They're only really used on 2 species of bacteria. One of them is significantly more common than the other one, Mycobacterium. Mycobacterium tuberculosis causes tuberculosis. Mycobacterium leprae causes leprosy. Mycobacterium avum causes Mycobacterium AIDS, avium complex. There's a bunch of these little species of Mycobacterium that cause problems in people. But anyway, they have a gram-positive type cell wall set up with their big, thick peptidoglycan layer, their one intermembrane, so they essentially are a gram-positive cell. But they do have an extra little thing added inside of their cell walls called mycolic acid. And you can see that over here, our gram-positive traditional cell, our gram-negative cell. And our gram-positive acid-fast has mycolic acid embedded inside of its cell wall, its peptidoglycan layer. That mycolic acid prevents crystal violet and things from binding to it. So you can't stain this guy with traditional methods. Methylene blue won't bind, things won't bind it very well at all. You have to find something that will bind to mycolic acid to stain these guys. The thing that's used to stain these guys is carbonyl fusion. So carbonyl fusion is our primary stain. You add it, and then once again you're going to add heat. Now mycolic acid forms this kind of waxy coating on the outside of bacteria, of these Mycobacterium species. You heat them up with a little bit of boiling water, a little bit of heat. That wax is going to slightly melt from the outside of their cell walls. That mycolic acid will melt a little bit. When it melts a little bit, the carbonyl fusion will stick to it. It's able to penetrate the cells a little bit better than it was prior to it. So they will start to uptake that color. Then you're going to remove the heat and wash away the carbonyl fusion. So you leave just the acid-fast bacteria that are having that mycolic acid with that decolorizer, with that carbonyl fusion stuck to them. Carbonyl fusion doesn't stick to anything other than mycolic acid permanently. You add the water. Anything that's not mycolic acid that has carbonyl fusion stuck to it will have the carbonyl fusion washed away, or excuse me, acid alcohol in this case. And then you add our counter stain so you can see everything else. So in this case, the counter stain is usually methylene blue. So you see down here, these purple guys are all our gram-positive acid-fast bacteria. You can see them over here as well. There's 2 types of acid-fast stains. This is a positive type acid-fast. This is a negative type acid-fast. You don't need to know the differences. But you can see here our acid-fast is purple. Our non-acid-fast, just regular old commensalistic organisms, or maybe this is another organism that's causing a problem in our patient, is non-acid-fast. And you can tell that due to the fact that it did not uptake that carbonyl fusion. It did not have mycolic acid bound inside of its cell membrane or cell wall. And that's pretty much all I got for you guys on the types of stains that are commonly found in microbiology labs. If you have any questions on this, guys, please feel free to send me an email. If not, have a good rest of the day.